video. It may be just slightly different, but ultimately it's all using the same skills we already had. In this problem, I'm given A is 32, the angle. C is obviously 90. Side C is 13. Okay, so what I would do is I like finding the easiest things first, because then the other things are easier to find if you have more information. The other angle has to then be 58. Again, just because the three interior angles have to add up to 180. And this one's 90, obviously. Okay, at this point, we need to know, this side and this side, and it just depends on which angle you want to take the perspective from. I've been using B a lot, so maybe I'll use A this time. If I chose A, then this is the opposite side, and this is the adjacent side. So I can't use tangent because from A because I don't have either the opposite or adjacent. I need to have at least one of those known. I could use sine because I know the hypotenuse, or I could use cosine because I know the hypotenuse. Again, I'm going from A this time. So I guess, I don't know, I tend to like sine the best for no good reason. So this looks like sine of 32 degrees is side A, that's the opposite, over the hypotenuse, which is 13. At this point, nothing is new here. Same thing we've always been doing. This is I cross multiply. You could also just say A is being divided by 13, so just multiply both sides by 13 to get A by itself. That's perfectly reasonable. I've just been consistently always doing this in case you can't just do that one move. So this is, sine 32 times 13. It's good to know that you're closing those parentheses off. Is equal to A. So on the calculator, I have sine of 32 times 13. And I get 6.9. That was this opposite side. And now you could, maybe I'll use trig again this time to figure out the other side. Everything's the same. I would just use cosine this time because that gives me adjacent and hypotenuse. Cosine of 32 is the side B, which is adjacent to A, over 13. And this is the exact same cross multiplication thing. You're going to get cosine 32 times 13, which is B. Cosine 32 times 13 is 11, just 11. Alternatively, just so we're clear, I probably don't really need to do this, but if we didn't know that side and we didn't want to use trig, we could just use Pythagorean theorem again. We could say that this is, 6.9 squared. This time we don't have side B, so it's B squared is 13 squared. And what that does is it gives us, try and show all my work here, 47.61 plus B squared equals 169. And we have to move this guy to the other side. So subtracting it off. $121.39, and then you're square rooting both sides to get B to be equal to 11.01. So again, I got 11.0 both times. It worked out either way using either method. Okay, so that was another example. This time we used trig to figure out what this was, and we had an option to use Pythagorean's theorem or trig again to find the other side. And we have to kind of, it's harder to visualize, but we're going to end up drawing a right triangle here. So we did briefly talk about angle of elevation, and what that is it's the angle created by like a horizontal, like maybe it's the ground or whatever, and then how many degrees up it is. That's the angle of elevation right there, between those two angles. So let's just see what we have going on here. 100-foot building casts an 88-foot shadow. So here's my wonderful drawing. There's a building, there's a door, and it's 100 feet tall. And it casts a shadow. Shadow's going to be on the ground here. Casts a shadow 88 feet. This is obviously not drawn to scale, but if the shadow's 88 feet, what's the angle of elevation of the sun? So we're going to say that this is, like the ground is the horizontal. It's like what must the angle of elevation be to make this shadow this long? And so there's our triangle. And we're looking for that angle. I'll call it theta. So, like, if this shadow's shorter, then the angle of elevation would be, like, let's say, like, if the shadow's only this long, then the angle of elevation here, you can see this angle's like bigger. The sun would be like higher up here to only have that shadow that long. But as it stands, the sun must be over here so that the building is creating this big of a shadow. Anyway, so that's just hopefully a better explanation of what I just said. So we have these two sides. This is 100, and from theta, that's the opposite side. And from theta, 88 is the adjacent side. So opposite and adjacent is tangent. Tangent theta equals 100 over 88. And then we need to use inverse trig again for that. That would be theta is arctan or tan inverse, whichever way you're calling it, of 100 over 88. So again, the only tricky part here is just making sure we can set up everything, all right. And my pictures are great, so have fun with that. I got theta to be, I'm gonna say about 49 degrees. It's 48.65 or something. 49 degrees. So that would be the angle of elevation of the sun. And keep in mind that like this could be an angle of depression. Not this problem, but sometimes you'll see angle of depression. That would be like, maybe you're on the top of a building and you're laying down and you're looking out, and you look down, you see a person down there, and what's the angle of depression? So the angle of depression is created from the horizontal that you're at down to what you're looking at, and that would be theta there. So that's just the two, elevation and depression, that we've talked about before, but that wasn't really in this